Welcome back, everyone. Let's go ahead and look at the Now You Try problem solutions for graphing functions with graphing trinomial quadratic functions where the leading coefficient is 1 that can factor. So our first example is capital H of x equals x squared minus 5x plus 6. And I want to find the vertex first. I just like finding that middle point to begin. So for the vertex, the x value of the vertex is negative b over 2a. That's going to be a positive 5 over 2. That's 2.5. Not the greatest number, but I think it'll be okay for us. For the y value of the vertex, we're going to plug that x value into the function. We'll get capital H of 5 halves. This is going to give us 5 halves squared minus 5 times 5 halves, and then a plus 6. We'll start simplifying this. We'll get 25 over 4 minus 25 over 2 plus 6. We need to get a common denominator. That'll be 25 over 4 minus 50 over 4 plus 24 over 4. I'm getting a common denominator with all three of these. Adding these up, we'll get negative 1/4. Oh, again. All right, so I'm going to make a table here. And my vertex I'll put in the middle of this table. I've got 2.5 or 5 halves and negative 1/4. And then I'm going to find my y-intercept. It's going to be at h of 0 equals 6, so the point 0, 6. So that's going to be to the left of 5.5. Let's put it right here. For now, we'll see if we have to move that. And then if I want its mirror, I'm going to take this distance, that's 2.5, and I'm going to double it to a 5, and then this y value of 6 stays the same. So that mirror point is going to be the point 5, 6. I can start graphing at this point. This is where I usually like to start graphing things out. I'm going to have the y-axis more to the left, so I have more room to the right, since I see these x values so far are all positive. It looks like the lowest y value is going to be at that vertex of negative 1/4, so I can start my x-axis down pretty low. So let's see, let's do 2, 3, 4, 5, 6. I'm going to go and just stretch this out horizontally. Let me see some of these half values. And in fact, I think I can do that. 2, 4, 6. Do I want to do that in the y direction? I kind of do. 1, 2, 3, 4, 5, 6. No, let's just do this normal in the y direction. 4, 6, 8, 10. So I've got that y-intercept of 0, 6. Got 2.5, negative 1/4 for the vertex. And we've got that mirror point of 5, 6. And we want the x-intercepts. We'll say 0 equals x squared minus 5x plus 6. To factor this, I'm going to say 2 sets of parentheses, x in the first position of each. I want two numbers that multiply to be 6 and add to be -5. So I need a -2 and a -3. This is a tricky one. This one can throw people off because we might think that it's a +1 and a -6, but that would multiply to be a -6, and we need this to multiply to a +6. So we need the -2 and -3, and this will give us the x minus 2 equals 0, or x minus 3 equals 0. So x equals 2 or x equals 3. So our x-intercepts are the points 2, 0 and 3, 0. So it looks like I can put these in here. 2, 0 and 3, 0. And I do want to move now the y-intercept and its mirror up a bit, or out a bit on my table. So I've got room, and I can plug in a 1 and a 4. Those are symmetrical. So if I do h of 1, we'll get 1 squared minus 5 times 1 plus 6. And this equals 1 minus 5 is -4, plus 6 is 2. So both of these should output 2 since they are symmetrical. And we can plot those points, 1, 2, and 4, 2. Label my points. Draw our parabola as a nice U shape that goes through all of them. So we get, label this y equals capital H of x. There we go. So we had a little bit of fractions to deal with there at the beginning, but we kind of managed to avoid them after that. Not too bad as long as we got through the y value of the vertex. All right, let's do another one. The next problem is j of x equals x squared minus 2x minus 48. We'll go ahead and start with the vertex again. The x value of the vertex is going to be -b is a 2 over 2 times 1 is a 1. That's nice, nice whole number here. The y value of the vertex is going to be j of 1 equals 1 squared minus 2 times 1 minus 48. So this is going to be -49 when we add all of those up. And then we want the y-intercept. And so we'll say, what's j of 0? And we'll get -48. So we get the point 0, comma, -48. Oh, the vertex point is 1, comma, -49. And then the mirror, let's take a look. If I set up the table, it kind of helps me see it. X and y. In the middle, I'll put the vertex. That's a 1 and -49. The y-intercept was at 0, -48, and its mirror should just be on the other side of the vertex. That should be then at 2, -48. So then we want the x-intercepts. I could start graphing, but I'm kind of on a roll, so I want to do this. I'm going to go 0 equals x squared minus 2x minus 48. And with this, we'll factor, we'll get 0 equals x, parentheses, another set of parentheses, x in the first positions. I need a -48. I'm going to do this a little faster. I think of numbers that multiply to be -48, so one positive and one negative, and add to be a -2. So their difference should be 2. 6 and 8 multiply to be 48. a positive 6 and a negative 8 would add to be a negative 2 and multiply to be negative 48. So I could say x plus 6 times x minus 8 is the factored form of our function. And we can set that to 0 and solve. So x plus 6 equals 0, or x minus 8 equals 0. So x equals negative 6, or x equals 8. So our x-intercepts are the points negative 6, 0, and 8, 0. Now there's some pretty big gaps here. I think that if I put like a negative 3 in here and a 5 here, that's kind of like the halfway between these. And so if I say what's j of negative 3, I'll get negative 3 squared minus 2 times negative 3 minus 48. This equals 9 plus 6 minus 48. And that adds up to 15 minus 48. Negative 33. Let's take a look at all those. We might even decide that we want to add more points. These are pretty spaced out in the x direction. The x's are going all the way from negative 6 to positive 8, so I'm going to have a pretty wide graph here. All the y values are very negative, so we want to put the x-axis pretty high. Got 4, then 8's over here, so we've got that 8, 0 x-intercept. Negative 4, negative 8, so negative 6, 0 is the other x-intercept. Then we've got the points. All right, we need to get all the way down to negative 49 here, so let's plan this out. Here's 5 grid lines, 10, 15. I'm going to even make this go down farther. 1, 2, 3, 4, 5. That's, and I'm going to go down one more set so that I can do by 2's. All right, so if I go by 2's, this is negative 10, negative 20, negative 30, negative 40, and negative 50. So 1 comma negative 49 is going to be down here. And then 0, negative 48, and 2, negative 48 is the y-intercept and its mirror point. And then we've got the points negative 3, negative 33. It's here. And we've got the point positive 5, negative 33 is here. Now, we could add in some more information, but I think we've got enough points here. We've satisfied the requirements of the question, and I think if we're just real careful, we want to get this to make a nice U shape through all of these. Make sure we've got a curve, not a V shape. And we'll label this y equals j of x. There it is. There's our graph. Go ahead and pause, rewind, look at all the parts that you need to make sure you had graph, the same intercept, the same y-intercept mirror, and the same vertex. You've got the right answer still. right, thanks so much for watching, everyone, and until next time.